In order to simplify, we need to simplify each radical. So square root of 3 is already simplified. Square root of 12, that's 4 times 3. So square root of 4 is 2. Square root of 3, and then 48, that is 16 times 3. And the square root of 16 is 4. And then square root of 3. Now, since we have the same index, they're all square roots, so index is 2, and the same radicand, square root of 3, square root of 3, square root of 3, they're all alike, we can add. So it's 1 minus 2 plus 4, which is 3, and then you just keep the square root of 3 that was common and made them all like terms. Very similar idea here. It's an index of 5, which they all have. So we just need to simplify them down to see if we can combine them. Since the index is odd, the negative can be pulled out. And then 64 is 2 to the 6th power. So that means there's a complete set of 5, 2 to the 5th power with an extra 2. It's negative, so we can pull the negative out as well. And then the extra 2 that's left over goes back inside. And then 486, that is 2 times 243. And then 243 is 3 to the 5th power. So the 5th root of 243 is 3. And then the 2 remains in the radicand. So we have all the same index. We have all the same radicand. Now we just combine them. So negative 1 minus 2 minus 3. It's negative 6. 5th root of 2. Keep the index, keep the radicand. Cube root, so it's an odd index, the negative can come out. Now they have the same index, the same radicand, so we add negative 1, positive 1, we get 0. For this one, I would start by getting rid of the negative exponent. So the a to the negative 5th, move it to the numerator and change the sign. Make it a positive 5th power. And then we're also going to need to rationalize the denominator. So we have b to the 6th. That's already a perfect power of 6. So we can just begin simplifying. The 6th root of b to the 6th is just b. And then a to the 12th is in our numerator, all combined here, which would be 2 sets of a to the 6th, since we're looking for 6th roots. So we have a squared coming out. You could also just think of dividing the exponents, 12 divided by the index of 6. But then this 5 is left over. Keep it inside the radicand. Since we have quite the fraction going on here, I would reduce the fraction as much as we can first. So 18 and 2, you just get a 9. A to the 3rd over a to the 1st, you subtract the exponents. So you get a squared. B to the 5th over b to the 2nd, subtract the exponents, you get b to the 3rd. And then c to the 7th over c to the 3rd, subtract, you get c to the 4th. Since this is a square root, the index is 2. Square root of 9 is just 3. Square root of a squared is just a. square root of b to the third, you could think of that as a fraction, 3 over 2. So it's 1.5, so 1 comes out. The 1/2 goes back in, it's a square root of b. And then c to the fourth, again, you're dividing 4 divided by 2, you get 2, so c squared out. So again, I would simplify this big fraction first. We have an x squared and an x to the negative third. So that x to the negative third would really come up, make x to the fifth. Y to the negative 1, y to the second. Move the y to the negative 1 down, you get y to the third. And then z to the fourth and z, you subtract those, you get z to the third in the numerator. We have not done anything with that exponent yet, so now we need to distribute the exponent, multiply, so we get x to the 10th, z to the 6th, and y to the 6th. So here we have a 1/2 power, that just means square root. So then it's just 4. Negative 1/2 power. So the negative means we need to flip this fraction to be a 36. And then 1/2 just means square root again. Square root of 36 is 6. Here we have a square root, it's 1/2 power, this time negative 25. This is not real. We can't do a square root of a negative. You might just remember that that's an I, an imaginary number. Square root of 25 is 5, so you could just say 5i. One-fourth power means it's the fourth root. And 625, that is a perfect power. That is 5 to the fourth power. So it's the fourth root of 5 to the fourth power, so that's just 5. Eight to the 2/3. The denominator is our index, so it's the cube root of 8. And then the 2 is the power, it's squared. It actually doesn't matter if you square first or square at the end. I'd prefer to square later because it's a little bit easier. Since we can do the cube root of 8, that's just 2. This is 2 squared. So the final answer is 4. Negative exponent, so that's going to become a fraction, 1 over 36 to the 3/2 power. The denominator of 2 means we're doing the square root. So we have a square root of 1 and the square root of 36. And then the exponent of 3 means we'll cube those answers. So square root of 1 is 1. Square root of 36 is 6. And then we just have to cube those answers. So 6 to the third power is 216. So that's 1 over 216. So the denominator of 5 means fifth root. Since it's odd, we can do that with a negative. It would just be negative 1. And then raise it to the third power, still just negative 1. Now, since we are subtracting, we'll simplify each one separately. We have 32 to the 4/5, so that's the fifth root. And we'll raise it to the fourth power. Similar here, but since it's a negative exponent, it becomes 1 over. So now we will do the fifth root of 32, which is just 2. So the 4th power. And then minus 1 over the 5th root of 32 again is 2, again to the 4th power. So that is 16 minus 1 over 16. And to combine those, we want them to have a common denominator. 16 times 16 is 256 over 16 minus 1/16. So the final answer is 255/16. We have a radical inside another radical. You just multiply the indices. So we have 2 times 3 for our index. Keep the radicand, and nothing will simplify. When you're multiplying and they have a different index, write them as a fraction or a rational exponent. So we have a 1/3 power and a 1/2 x power. And we just need a common denominator with our exponents now. So that's denominator will be 6. So make this be 2/6. And this would be 3/6. So now the denominators are the same. That is your index. That'd be a 5 to the 2nd power, 10 to the 3rd power. Multiply that out. So that's 25, 10 to the 3rd power. It's 1,000. So 25 times 1,000 is 25,000. And it's the 6th root.